This is Dr. Daya Sagar Chowdary, Senapati, Assistant Professor, Department of Electronics and Communication Engineering, Aditya University. Today we will discuss about the topic encoders and decoders. So before going to encoders and decoder concept, learning outcomes we have to discuss. At the end of this lecture, student will be available to explain and design and implementation of the encoder and decoder circuits, and also construct their corresponding truth tables, derivation for Boolean algebra expressions, and apply these circuits in digital system applications. This is the learning outcome from the student. So this is an encoder circuit. So an encoder is nothing but the code conversion. Simply we call this one as a code conversion. That means in one form of code is converted to other form, that is the code conversion. We call this, mostly encoders are used in the code conversion process. So an encoder is having an equation. Mostly we discuss about the equation, that is 2 to the power of n is to n, or 2 to the power of n into n. So here we represent 2 to the power of n is the inputs and that n is the output. That means here 2 to the power of n into n, we call this one as a into, or 2 to the power of n is to n. So we can consider this 2 to the power of n is the inputs and this n is the output. So that means here 2 to the power of n inputs, so the inputs are varying according to the 2 to the power of n and to 2 multiples, and n is the output. So depending on this power, so this is the output. So here an encoder is a digital circuit that performs the inverse operation of a decoder. So anyway, we will discuss the decoder concept in the same class. An encoder has 2 to the power of n input lines and n output lines. So here we already discussed about that concept. Now here the simple circuit, this is a simple circuit, so which is of having one OR gate. So one input is directly given and other input is given with the help of one inverter circuit. So finally we will get the output, that is x. So here this is a simple 2 to the power of 2 to the power of 1 into 1. This is the 2 to the power of 1 is 2 multiplied 1. That means 2 into 1 encoder. So for a 2 into 1 encoder, it contains 2 inputs, that is either 0 or 1. Now if x is equal to 0, output is x is equal to 0, so one input is enabled, and if x is equal to 1, the other input is enabled. So likewise we have to construct this entire truth table. So if we draw a k-map for this particular x, so finally x is equal to, so if we want to design a k-map, Karnaugh map, so for x we have to enable, because x is equal to 1 when d1 is equal to 1. So that is the corresponding inputs, this is the corresponding inputs for this x is equal to 1. That is why we are simply writing the equation capital X is equal to 1 d1, that is output is equal to directly d1. Likewise we have to construct this is equation and the corresponding truth table. Now this is the binary encoder, we call this is a 2 to the power of 1 encoder circuit. So d1 and d0 and d1 are the inputs and x is the output. So let us consider the encoder 4 to 2 encoder. So 4 to 2, again 4 to 2 or 4 into 2 or 4 is to 2, we can consider anything. So 4 to 2 encoder so contains, so here we can write the 4 into 2 to the power of 2, that is 4 multiplied to 2. That means here 4 inputs and these are the 2 outputs. That means from y0 to y3, so y0, y1, y2, y3 are the 4 inputs and these outputs are a0 and a1. So here this is a 4 to 2 encoder. So an encoder is a digital circuit that performs the inverse operation. Again that is the same representation of the definition, and an encoder 2 to the power of n input lines and n output lines for the same, because this is also just a bit increment. Now this is a 4 is to 2, so it contains y3, y2, y1, y0. These 4 are the inputs and a1, a0 are the outputs. And coming to, these are the equations whenever a1 is equal to y3 plus y2 and a0 is equal to y3 plus y1. So this will comes from the truth table. So the outputs are A0. If we consider A0, so here the 1 is there, here 1 is there. That means we have to concentrate on these two outputs. That means we have to concentrate on this particular corresponding inputs. So we can easily identify these inputs. So we can consider this one as a Y0, Y1, Y2, Y3. So if A0 is equal to 1 whenever Y1 plus Y3. So that this is the equation, Y1 plus Y3. So this is the equation for this A0. For A1, so we can simply write it as, so here 1 is there, here 1 is there. So we have to consider this combination and here this combination. So 1 1 combination, so that is Y2, the corresponding one is Y2 and Y3. So Y2 plus Y3. So this is what the equation we have given here. That means this is a simple 4 to 2 encoder. So this is the simple circuit construction for this particular equations. So we represent the inputs with Y1, Y2, Y3 and A0, A1. So here a simple conversion, that is Y0 is missing actually. So we will discuss that Y0 also later. So most of the time I already told you, so these encoders are used for code conversions. So that means here the heading is also we convert that octal code to binary code. That means octal encoder, so octal to binary encoder. So this is a simple representation for 8 to 3. Why? Because if 8 means 2 to the power of 3, that is totally 8. 8 to the 8 we can write it as a 2 to the power of 3, and 3 which is nothing but the output. So 2 to the power of 3 into 2, 3. So that means 8 into 3, that is totally 8 to 3 encoder. So that is why it contains Y0 to Y7, totally 8 inputs, and your output, our outputs are A0 to A2, that is A0, A1, A2. And this is a simple construction of the truth table. So we can represent the inputs from Y0 to Y7. So Y0 is the LSB and Y7 is the MSB. So likewise we can consider from Y0 to Y7. So each and every time we have to enable one input. So remaining all the inputs are zeros. So here you can observe that all the corresponding output inputs are zeros in the both triangle shape. So that means only in the cross only we are using the ones. So for this particular one, so we are assigning one combination, that is binary combination. That means simply 0 0 0 0 0 1, from 0 0 1 to so many, that is 0 1 1 1. So this is the simple combination which is represented as that binary combination. That means for each and every input enabled, we are assigning one binary combination. This is the simple conversion of the octal to binary. If we want to again what is A0 and what is A1 and what is A2, according to we have to obtain these outputs, that is A0 and A1, A2, so that we can consider with the help of, we can place this one as a Y0, Y1, Y2, so on up to Y7. Then it will be easy for us to construct an equation, so that we can take. So if you observe this one, A0 is equal to Y7, Y5, Y3, Y1. So if we consider this A0, so A0 is nothing but, so this one and this one, this one, this one we have to consider. So these 4 ones, so the corresponding inputs, this is the corresponding input 1, that is Y1. So that is why we have to place this Y1 in the A0, and the corresponding here 1 is there, the corresponding 1, that is Y3. So this Y3 we have to place, and here 1 is there, so here the corresponding 1 is there, that is my Y5. So this is Y5, and one more 1 is there, this is 1, the corresponding input 1 is there, this is Y7. So this is Y7. So A0 can be constructed with the help of Y1, Y3, Y5, Y7. So with the help of summation of all these inputs leads to the output A0. So likewise A1 is also constructed with the help of the ones. So here 1 is there, here 1 is there, 1 1. So again 4 ones. So we have to consider the corresponding input. So this is the corresponding input, that is Y2. Here for this one, this is the corresponding input, that is Y3, and here the corresponding input here, that is Y6 and Y7. So that is why this equation is constructed with a summation of Y2, Y3, Y6 and Y7, that is A1. Our output is A1. For A2, so we can simply construct this one all the 4 below 4 ones are there. So we can construct directly from here, 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 here. These all 4 are the ones, and y4, y5, y6, y7 are the corresponding inputs. That is why A2 is the summation of all these 4 inputs, that is y4, y5, y6 and y7. So this is a representation. The after conversion of this equation, now we can simply construct a circuit. So depending, if we observe clearly, the equations all are summation. So that is why simply we can use the or operation. So each and every input. So if we observe, inputs are from y1 to y7, but here y0 is missing. But if you observe in previous slide, y0 is also there. We have to give the priority to the y0 also. That means for the combination of 000. But anyway, here the y0 is missing. Finally, we will get the encoding, that is encoding, that is with A0, A1 and A2. So this is the simple block diagram that is represents with 8:3 encoder. So 8 inputs and 3 outputs. Mostly we will represent 8 inputs, 3 outputs, but the problem is if we observe at the output side, y0 is missing in the 3 equations. So this is one of the drawback for this particular encoders. This is one type of priority encoder. That means this is one type of encoder, but we have to consider this one also. So this is a priority encoder which we can give priority to the for particular operation. So let us see what will happen. So a priority encoder is an encoder that includes priority function. So if we consider the truth table, then you will come to know, so where we have to give the priority, at which point we have to give the priority also we have to consider. And if 2 or more inputs are equal to 1 at the same time, so the input having the highest priority will take the precedence. And if 2 or more inputs are given at the same time, so the input having the highest priority will take precedence. And an example, here we are already taken one example for this particular operation. So let us consider with the help of this particular truth table. So consider this truth table. So if you observe the same truth table, before that encoder which contains the zeros here, in place of cross mark, here there are zeros in the previous truth table. But while coming to here, if we observe, we are placing the cross mark. That means cross is nothing but we know already, according to the digital circuits, cross mark is nothing but the don't care condition. So don't care means, so whether this cross mark indicates, we can take, if we want, we can take 0, this one as a 0, or if we want this one, we can take this one as a 1. That means either 0 or 1 we can take in place of don't care. That means in place of cross mark. So here already represented the whatever the priority that is given to the right side. If you observe that one, cross marks are represented. But here in previous encoders we used that in cross marks zeros are there. So that means here cross mark is there means we can consider if 1 or 0, directly we will take the y1. That means priority is given to the here y1 only, not on y0. Here the priority is given to the y2 only, not on y1 or y0. And here the priority is given to the y3 only, not on y2 or y1 or y0. That means here if in place of this cross mark, irrespective of 1 or 0, we don't consider these cross marks. That is the reason we call this one as a priority encoder. That means simply we will give the priority in this particular positions only, not the other positions. For this particular positions only, we are assigning the coding techniques, that is encoding techniques, because this is a code converter. That is why we are using this code converter. Mostly we use this concept means, so previously we use the computers. In computers, 2 or more operations if we use at a time, then if the delay is more in the computer, then definitely we got a stuck means 2 or more applications on a single processor will leads to a delay. Then computer will come out with this problem with the help of this priority encoder only. That means it will assign the priority to each and every application and it will come out from that particular issue. So this is why we are using this priority encoder. That means we will come out from the that issue. So this is the priority encoder. As usual, we are simply calculating the k maps for the A0, A1. So here this A0 and A1 is the priority output. So we have to give the k maps for A0 and A1. So according to A0, A1, we know already it contains 4 inputs. That is why, so 4 inputs can be constructed with the help of 16 boxes. So 4 into 4, so total 16 boxes. According to the k maps, we are simply following this ones everything, and if we group these ones, if we group these 8 ones, because this is depending on the don't care conditions, that is why these ones are represented, and finally we will get the A1 is equal to Y3 plus Y2, and likewise A0 is also Y3 plus Y2 bar and Y1. So this, for this particular operation and for this particular expression, we are simply constructing a circuit diagram. So this contains the only OR gates, one AND gate, one inverter gate. Simply we call this one as this circuit called this one as a AOI. That means this circuit contains AND gates, OR gate and inverter. So or else we can also follow the sequence. Here inverters are first we used, and AND gates are second we used, and OR gates are third we used. That means we call this one as a level 1, this is level 2, and this is level 3. That means IAO circuits also we can define with the help of this priority encoder. Now these are the somewhat applications of this particular encoders. So application, so mostly we will use the code conversion. That means the first best encoding technique is keyboard encoding. That means if we press any key on the keyboard, so that according to that key, so it will convert, the code will be converted and that will be displayed on the screen. That means this is the best encoding technique we use for, in that particular position. We use the hardware encoding hardware, and this is the binary for processing. And interrupt handling in microprocessor, that is I already told you that in particular priority encoder, most of the time we will come out with that issue. So whenever there is a delay in the particular task, definitely we have to come out with that issue, from that issue. And digital communication system, most of the time in digital communication system we have to transfer the signal from one point to other point. Definitely there is a code conversion required. That means we are converting a code that is flexible for the towers. Then only that signal will be transferred to the other tower, and that tower again the code is converted to the device. So that is why our recent 4G technology or 5G technology will improve because of this code conversion, simple code conversion. And data compression, as we know already, so that can be compressed because inputs are 8 and outputs are 3. That is why the code is compressed, the coding technique is compressed, and most of the time which is used in memory addressing. So it simply addresses the memory because the data we can store within a few bits, and mostly used in robotics and automation. Why? Because automation and robotics contains very huge data, but here with the help of this encoding techniques we can convert within a less data or less bits, so that it can work accurately. And control systems, encoders provide feedback signals in servo motors and stepper motors. Most of the time we use that motor part, so it will give the input to the motors. And multiplexer controls, anyway multiplexer is a different concept, but anyway the inputs and inputs are same according to the encoder and the multiplexer, both are inputs are same, 2 to the power of n we will follow, but coming to the outputs there is a difference because multiplexers depends on the selection lines. So here the encoder is of having the limitation, that one we already discussed in the previous slides. That is, so Y0 is not mentioned there because Y0 we are giving any input, but the problem is we are not assigning at the equation side. That means Y0 is completely avoided in the particular circuit. That is the reason we are mostly avoiding that Y0. That means totally if we consider there are only 7 inputs, that means we are simply hiding that Y0. So that is the only big what we call this limitation in the encoder technique. And also if an encoder contains the inputs 2 or more ones, is enabled, again there is a confusion. We call that one as a ambiguity for this particular operation. That is the limitation for this particular encoders. So most of the time, sometimes we will use this priority encoder and sometimes we will use this particular encoders. Most of the time this requires additional circuitry if we want features like error detection, priority resolution or enabling functions. So this is the few limitations for this particular encoders. So coming to the opposite, we discuss with encoder means we are simply we have to use this reverse concept that we call it as decoder. So whatever the encoding techniques are used in the encoders, finally we will get some coding concept. That coding is provided by the encoders. Now we have to give these coding to the decoder as an input and we will get the same that output as the same input. Likewise that replica, this is the replica of the whatever that input we have given, that is the same replica of this particular output. That means decoder, whatever the output of the encoder given to the input as a decoder, and whatever the input in the encoder, that is the output for the decoder. So that is the same concept because this is the reversal of the encoder technique. So while coming to this, we call this one as a 1 to 2 line decoder. Anyway, here it will follow also n into 2 to the power of n. That means n is our input and 2 to the power of n is the output. That means here n represents the inputs and 2 to the power of n represents the outputs. Here this is the particular equation. If we are having any one of these four, that is why we represent this with arrows. That means if we have truth table, simply we can construct all the circuit, all these equation and this block diagram. Or if we have this block diagram, we can simply construct this truth table and the circuit and the equation. So that is why this is the procedure that any device or a circuit is of having. We can easily construct the others also likewise. So this is a simple, again whatever we are using at the output side in the encoders, that is the input right now. So here A is the input, previously X is the output, that X is 0, 1, here A is the input, that 0, 1, then same. So and their inputs, that is we already represented that D0, D1. Now here these are the outputs, that is D0 once enabled and D1 one time enabled. So we can simply construct a K-map for D0 and D1. For D1, here the 1 is there, that is the corresponding output, that is A bar, because A is in 0, that is why A bar, and D is in 1, D1 is in 1 whenever A is highlighted, that means D1 is equal to A. That is why these equations we used in decoders. Now this is the simple block diagram, simply represented with the two inputs with one input, because this is a 1 into 2 or 1:2 decoder. Now this is a simple construction for this particular equation of this is the circuit diagram. We can construct like this. Now coming to this 2 to the power of, we have to enhance the same 1 into 2 decoder to 2 into 4, that is 2 to 4 binary decoder. We can call any such type of terminology, 1 to 2 line decoder or 1 to 2 binary decoder or 1 to 2 decoder. Simply we can call that one any type of decoders. Okay, that is not a big problem. So here 2 to the 4 binary decoder. So here again 2 to the power 2 to 4, that means 2 inputs and 4 outputs. Here the representation is Q, Q0, Q1, Q2, Q3. And finally same, the representation is same, that is why I already given the cross mark, cross once. So this is enabled because we have to follow the binary here, because 2 inputs 4 combinations will erase, that means 0 0 0 1 1 0 1 1. For this particular operation, for 0 0 operation 0, here Q0 is enabled. For 0 1 operation Q1 is enabled. For 1 0 combination Q2 is enabled. For 1 1 combination Q3 is enabled. That means simply we can write an equation. If Q0 is there, Q0 is equal to enabled, that is 1. So for both inputs A, B are in bars, that means Q0 is equal to A bar, B bar. So likewise we can write an equation for all these Q0, Q1, Q2, Q3. For this particular operation, we have to construct this circuit also, like, because here A, B are the inputs, that is why A, B are the inputs, and one time we will give directly and one time again we are using this inverter circuit. So likewise for A and B also we are connecting the A and B directly, and one time we are connecting through the inverter circuits. Finally, we will use that AND gates, we will get the circuit, final circuit. That means here the operation is very simple, inverter with AND. So that is why the entire circuit we can construct. So we can enhance the circuit. That means we can enhance the circuit. So we'll see that in next topic. That is 3 to 8 decoder. So if we consider again 3 to 8 decoder, this is the block diagram. Again, it contains 3 inputs and totally out to 8 outputs. And if this is the truth table, we can consider all the 8 binary combinations. For this 8 binary combinations, each time we will enable the output. That means each one we will enable the output. Likewise, that means for this combination F0 is enabled, for this combination F1 is enabled, for this combination F2 is enabled, likewise for this combination F7 is enabled. Likewise, we will start our work. And this is the circuit diagram for that particular operation. That means 3 inputs are there. So again, it will follow the binary, and simply we can construct all the equations for F0 to F7. So these are the, it will follow the simply the binary. So this means X0, Y0, Z0. That means simply F0 is equal to X bar, Y bar, Z bar, because it plays a 0, 0, 0 combination. 0, 0 means inverter. After inverter only we will get the 0, 0, 0. That is why X bar, Y bar, Z bar. Likewise, we construct the equation. This is a simple work. And mostly we will get this decoder, that means higher level decoder to lower level decoder. That is why lower order implementation, we kept this one as a lower order implementation. That means this is a simple 8:3 decoder. We have to convert this one to 2:4 decoder. So for 3 to 8 decoder, 3 inputs and 8 outputs. For 2 to 4 decoder, 2 inputs and 4 outputs. That is why one input we have to convert this. Here if we observe A2, we can directly given to the terminal to the E, that is like enable, and once we will use this inverter circuit, finally we will get the, we have to give that input terminal to the other decoder. So likewise we can what we call hierarchy, sub module with the help of this particular 3 to 8 decoder to 2 to 4 decoder. So anyway, finally we will get the total 8 outputs and 3 inputs. So it is following the 3 to 8, but we are using only 2 to 4 decoders. Same, this is a 4 to 8, 4 to 16 decoder we have to construct with the help of 3 to 8 decoder. Same concept we have to use. The fourth terminal, that is here A3 is directly given to the one decoder and is invertly given to the other decoder. Finally, we will solve the issue. That means here the outputs are totally 16 and the inputs are totally 4. So it's which satisfies the our equation. So now the decoder is okay. Now any expression, any other expressions if we consider, that means here we have taken one full adder circuit, we have to implement this full adder circuit on the decoder. Now depending on the operation only, that means 3 inputs here, now we are having total 8 outputs here with the help of, because we can use this sum is the sigma, that is summation of 1, 2, 4, 7. Likewise carry is also 3, 5, 6, 7. So we can write this equation because the truth table is this one. So you can consider the full adder circuit truth table, and for that full adder circuit truth table we can consider this equation, that is sigma, and this is looks like a simple K map. So with the help of this K map we can take the terminals directly, whatever the numbers are there, that is 1, 2, 4, 7. So from 1 we can take one terminal, from 2 we can take the other terminal, and from 4 we can take the one terminal, and from 7 we can take the other terminal. So it will form a summation for this particular operation. That means we can simply construct a full adder circuit with the help of the decoder. So this is the procedure for any conversion of any circuit on decoders. But here if we observe this one, this is an equation. So any equation also convert into on a decoder. So we can convert this any equation on a decoder. This is the simplification method. That means, so this equation contains A, B bar, C bar. That means A we can consider like 1, B bar we can consider like 0, C bar we can consider like 0. That means 1, 0, 0 represents the 4. So 4 terminal is directly given to the OR gate. So likewise here A bar, so 0, B like 1, C bar 0. So 0 1 0, that is representation of 2, 2 is given to the OR gate. So likewise the other two terminals also we can connect to the OR gate. Finally we will get the output Y. So any equation that can be converted on a decoder like this. Now coming to the decoder applications, most of the time we are using these decoders for converting the memory address decoding, and at the same time 7 segment display driving. So mostly we use that 7 segment technology, and instructing decoding in CPUs, also demultiplexing concept. This is a simple vice versa for the multiplexing concept, and communication part, because we have to enhance the outputs, and digital to analog converters, because there analog to digital converters we are using, here digital to analog converters we are using in the particular that electronics part, and as well as the communication part. And peripheral selection is also applicable with the help of this decoders. And finally control systems, again the same automation and robotics, we are using these decoders. With the help of these decoders we can easily construct the circuits. Coming to the limitations, so increasing hardware, because the inputs are 3 but the outputs are 8. So we have to think of this 8 outputs. So if there is a combination, that is fine, but if the outputs are always, we have to keep these 8 outputs in on condition, switch on condition. That means definitely it will draw some power. That power may be unnecessarily, this here we already mentioned, power consumption increases because of this particular purpose, because always the 8 inputs are in on condition means, so it is a drawback for this particular decoders. And no error detection, so these devices are not involved in any error detection concept. And most of the time it requires stability of the inputs, because inputs are the code converters, but here there is no stability for this particular decoder inputs. And limited functions, this is only for particular just decoding concept only, so no other techniques it will use, so that is why limited functions. And finally power consumption, always I already told you, the total 8 outputs for a 3 to 8 decoder, total 8 outputs are in on condition. That means it simply consumes more power. So finally the summary is, the encoders convert multiple input lines into a smaller set of binary outputs, while the decoder performs the reverse by converting binary inputs into activated output lines. And these circuits also are essential for data selection, address decoding and code conversion in digital systems, and they form the basic building blocks for many digital and processor based application part. So these are the somewhat summary for the particular this encoder and decoder techniques. Mostly we use these summary for this particular encoder and decoder we use for code conversion methods. Thank you.